Hi everyone, welcome back to our channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and today we have one of our students, Ghassan, who has completed the ROS Basics in 5 days for Python, ROS2, I believe. And at the end of this course, there is a project presentation. And this is what we're going to be seeing today. It's Ghassan presenting his project in a real robot here at The Construct for that course that he completed. So hello, Ghassan, how are you doing?
Hi, Rodrigo, how are you? I'm fine, good.
I am good as well. I'm excited to see your presentation and the work you've done. So whenever you
Let
want,
me
you
share
can
the screen.
start sharing your screen and we can get started.
Okay, let's share the screen and okay, I hope you are seeing my screen.
Yes, we can see the robot.
Yeah, okay. So let me run the ROS bridge, which and connect it. Now I'll run my code and let's go. As you see now, the robot is finding the nearest wall. When it will reach this, it find it. Now it should keep 0.3 meter distance. When it will align the right side of the robot, it will start the wall falling behavior, and it will start also the readings, the ROS action readings. So it have now two parts. Now it's running. The first part is the wall following behavior part and the action reading parts. So as you see, the robot now it's doing the wall behavior part. It's supposed to make the robot to navigate around all this world. And when it will reach the same point that it starts from it, the robot will stop at that point. So now the robot's just moving around. Yeah.
Very smooth movement. Very nice.
Yeah, I'll tell you something. This is something that I did it. And this thing, ChatGPT helped me a bit.
Oh, that's awesome to hear. That is awesome to hear.
With like I see now in this new future, I think that when you will use ChatGPT, and there's some people they think that it's a type of cheating, but I don't think, because in the end, when you use this, you are like being more, how can I say, more professional.
Yeah, and efficient. I agree with you completely.
And as you see, the robot stops at the start point. Yeah. So
it stopped. Nice.
Yeah. This is the logic that we should do. And now let's start and show you how we solved it. And let me share my PowerPoint.
Awesome. Yes. Let's see it. We saw that your program works.
Did you see it, Rodrigo?
Yes.
Okay. So let's start.
Oh, I'm sorry. No, I can't see the presentation.
Okay,
I don't see it.
Share 1 minute. Okay. I hope all of you are seeing the code.
Now I see it. ROS2 Basics in 5 days. Yes.
So my name is Ghassan Esam, and I'm a student in the Construct Team platform. And I had finished the ROS2 Basics in 5 days course. And they gave me a project to do, the project that I show you the program or what the project is supposed to do in the start. And now I will show you how did I solve my project. So let's start and let's tell you about this course project. What was the project? In this course, in this part of the project, like in this course, we learned about ROS2, and we have 3 main things in ROS2: the topics, the publisher and subscriber, the services, and the actions. And in this project, like the main goal was how you will put all the things that you learned, services, actions, and topics, how you can connect them in one thing and do like, how can we say, a program with a robot, a real program. So as you see, we was having 3 parts. The first part was we will implement our topic skills to do a wall following behavior. Then we will go deep under it. Down we will go deep. But this is the first part. Second part was on the services. We should do a service server that lets the robot to find its nearest wall, so then we can run the wall following behavior. And the third and last one was on the actions, because of course, if you finish the course, you should know all these things, so you should be able to do them in a project. And it was the third part to use the actions to to calculate the robot distance moved, the distance moved by the robot. So as you see this, the robot's word that we should use it. And now let's start. The first part, which it is the wall following behavior part. In the wall following algorithm, we were tasked with programming the robot to navigate to its environment while always keeping the wall on its right side. My approach was based on the robot's right side laser readings. If these readings exceed 0.3 meters, no. So now I will only tell you. So how we should do it? We should let the robot, it should go around this whole world, keeping its right side aligned with the wall, but this with the wall. If the robot side was bigger than 0.3 meters, the robot will go a bit at the right, like it will be like crashing the wall. Then when it will be 0.2 or smaller than 0.2, then it will come back. So in this way, maybe we'll have a smooth something, or we will be able to make it in a straight way. Yeah. Will be like able to make it in a straight way. So this is the thing I use it. And this logic, it helps me, like, and using this logic, I code that I did not make it in zigzag mode, because when it will be between 0.3 and 0.2, it will try its best to make it smooth at because it will try its best to make it aligned with the right wall and between the 0.3 and the 0.2. So this is the first part, and this is how I solve it. So let's go to the second part, and it's the finding wall. Now, we know that, as I told you in the start, the wall filling behavior cannot start if the robot is not aligned in the right wall. So in this finding wall part, we are using the service so we can make the robot, or we can align the robot so its right side will be to the wall. So the first thing in this, you should put a robot in a certain place, and you should start to rotate the robot. And the robot will be seeing, because using the leader rating, it can see the 360 readings around it. So the robot will start rotating until it see the laser minimum index, which it will get it. You will program it in your program. When it will find the minimum index, which means the minimum wall, or the minimum distance to a wall or an obstacle, so then it will move, it will be towards it. When it will be towards it, it will be moving forward. It will be moving forward until the distance will be 0.3, because also in the wall following behavior, they want it from us to be 0.3. Then it will again turn it, so then the 180 of the robot will be with the wall. Okay, so this is the second part. Now let's go to the third part, and it was the action part. The logic in this part, like because it's so deep part, and it was the most hardest part to me.
Okay.
Yeah. But how can I tell you? In this part, the logic that I use, that I like, how can I say? The first point, the robot will start moving from it. It will be then counting the new points with that point. When the robot will see that this point has it's the same as the last point, then the robot will stop at that place. Maybe the robot will not be how can I say? It will not be can I say perfectly at the same place,
yes.
but it will be like a bit a distance, but it will be like, it will give us the thing that we wanted to do. So this is the 3 parts, and this is how I solve it. And let's talk about the challenge a bit. Then I will show you my codes. So the challenge, there's 2 main challenges I faced in this course. I know something. The real is not at the simulation. Very, very, very big difference. And this is something that in the course you did not mention it. It was like a challenge for the student. You should know it with yourself. What is the big difference between them? In the simulation, the robot readings is 360. Between every one value, there's one, like 1, 2, 3. But in the real, it's not like this. In the real, it's 720 values. So between every value, 0.5. So 0.51, 1.5, like this. So this was a very big difference. Let me give you an example. Like in the simulation, robot right side was 270 degree, or what value we can say. But in the real robot, it's 180. So there's something. And there was I think that I was having a trouble in it, and I don't know where is my trouble. Also, I messaged the robot identity very think that the robot's teacher can help you and like this. So I was having a problem. That in the simulation, the forward readings can be 0 or 359. Yes,
Yeah.
value. Yeah. But in the real robot, no, 0, it's not for the forward, only 359. 0 is for the backward. So when I was putting the forward readings at the 0, in the simulation, it works well. But when I go to the real robot, it don't work. And I don't know why. When I message the robot identity, they tell me, what's your main problem? I don't know how to describe it to them because I did not know my main problem. So then one of the teachers, very thanked him. He helped me. Then we solved it together. He told me that the readings like this and like this. So this is the first challenge that I faced. The second challenge was the challenge of the zigzag button. I did not know how can I make it in a straight path. Like it was only going in a zigzag. I don't know why. Because also in the course project, it was not mentioned you should make it in a smooth or a straight path.
No.
If you want to make it in a zigzag pattern, it's good. There's no any problem. But it's a professional thing from you that if you will make it in a straight.
Yeah.
So I was thinking with ChatGPT, and we was thinking and we think. He told me that he told me about this line. What this line it could do as I told you, when you will make it between 0.3 and 0.2, the robot will try the minimum index. We will minus it with the robot right side, and we will multiply it with the lowest, or how we can say, the lowest speed. So the robot what our eyes see, that the robot is moving in a straight path, but it's not like this. The robot in the real it's curving, but a very slow curving, so our eyes cannot see it. Yeah. So this is
that's
something.
awesome.
Yeah, this two challenges. And maybe the challenge number 3, I didn't mention it because it was not a big, but then I want to discuss it with you, Rodrigo. It was the callbacks challenge. Challenge. I did not understand the main logic of the callback. Till now, I understand it now, but not the full, how can I say, fully understand it. Because, it was a very, I would not say it's a hard thing, but it was a very deep thing.
Do you mean the subscriber callback or your server callback?
No, I'm talking about the main callback idea. Now,
Okay.
Rodrigo, can you tell me how can the callbacks benefit me? I know it can block, and I know about, because I was having a problem in when I started the project. The first thing, I did not mention any callback in my codes, and I did not add them, and I was having problems. Then one of the teacher, he told me about the case when it will block on you. Like if you want to take the readings of the laser scan in the same time you want to move forward, if you do not use it, it will block or something like this. But the thing, I did not understand it. Now in ROS1, we were not having callbacks. So how it was working in ROS1 and in ROS2, it don't work.
Well, there is callbacks in both of them.
In ROS1, there is callbacks?
In a subscriber, every time you have a subscriber or a service server or an action server, at the end, you put the arguments, and then at the very end, you put its callback, which is the function that is going to be calling every time. Makes sense for the LiDAR. Think about it. Every time you get a new reading, this callback gets executed. But yes, you're correct in saying that ROS1, you didn't have to worry about the blocking of 2 callbacks. Let's say you're reading the laser, and then you also want to move forward based on those readings. In ROS2, you get a blocking situation just think about it, because of the structure of ROS2, and because this way you can now work with separate callbacks doing different things to manage different sensors. Because if you have many subscribers, you'll have many callbacks. Let's say you have a sensor for your odometry, because you probably do in your action server. Then you run that callback within another callback inside your main action server. But yes, basically just think of it's because of the architecture that ROS2 needs this and ROS1 doesn't. They did some extra work in ROS1 to kind of take care of that for us already. So in the background, it's still happening, but it's hidden. And this way, it allows in ROS2, it allows for more control if you're getting really deep into the functionalities of these callbacks. So that's probably that's the explanation for that. But
So until now, like I finished my presentation. You want me to show you the code first or the code?
let's look. I'm fine not seeing it if I can ask you some questions instead.
Yeah, no problem. Take
Yeah?
it.
All
Yeah,
right.
ready.
So do you mind stopping sharing your screen so we can
Yeah.
kind of see each other here?
Okay, I stopped sharing my screen.
All right. Well, let me tell you, first of all, Ghassan, congratulations. This is
Thank you.
an amazing project. I have
Thank
to tell everyone that Ghassan here is the youngest student I've had the pleasure of listening
Thank
to
you.
a presentation. So it's very encouraging to see that you have such a good grasp of the course and to see
Thanks.
that program and your project was so well executed. Let me
Thank
tell
you.
you some things that I really liked about your project. First is the fact that that you weren't satisfied enough with your zigzag movement of the robot of the wall following, and then you went a step further because you wanted to make it smooth, and you asked help for ChatGPT. I don't like you said. I completely agree that there's nothing wrong with that. Even it's even better because you can think about it as like 20 years ago, people would say, "Oh, Googling something is like cheating. You have to go to the library and take out the
Also,
book."
yeah, there's also some people they are saying like what they're saying that you should not go to ChatGPT. You should start from your beginning. But if there is something, it's already there. Why you don't take it and you improve it? Why you should go again to the first step number one and do it from scratch? It's already there. Take it and improve it.
Absolutely.
Yeah, that's
And
my.
you can't rely completely on things like ChatGPT because it might be wrong and you might not even realize it.
Yeah, of course, really, ChatGPT, sometimes it was going, it was giving me a library's name that it's actually there's no.
Yeah,
It was
or the
giving
type
me
of
something,
message, things like that, right?
yeah,
Yeah.
and cheating, yeah.
But I'm super happy to hear that you've used it in order to improve your robot program.
Yeah,
That was awesome. And so, other than that, I have a couple questions for you.
yeah, take it.
All right. You said that in your service server that finds the wall, uh, it it gets the minimum distance, and then it goes to the wall, and then it rotates kind of to get ready and aligned to start. How
Yeah.
did you rotate? Did you do that based on time, based on the odometry, or how did you turn at the last step in order to make sure that you were actually aligned with the wall?
Yeah, you think, yeah, I'm using the laser minimum index. When the laser
Uh-huh.
minimum index, it will reach the like 180 because I know that 180 is the right distance of the robot. So when it will reach 180, then it will give that it finished the wall finder like how can I, the wall finder logic. So then it will start the wall following logic.
All
I
right,
use
awesome.
laser readings. Yeah.
And if I understand, your code will make it go to the nearest.
Rodrigo, this.
Yeah?
Uh, Oh, and something because I did not heard the last word. There was a glitch in the internet.
Oh, okay. I was asking. So it will go to the nearest wall or the nearest obstacle, right? Because if you start it from the
Yeah,
really beginning,
yeah. See, the real, yeah, because you did not mention in in the project that you want it on the wall or an object. So because I did it in the wall.
no, we didn't, and
Yeah,
I'm not. This is not like, hey, this is wrong or anything. I'm just
yeah, I know.
in the spirit of improving, like you did for the Chat GPT part of smoothing.
Yes.
You can just a suggestion for your future projects for your
Yeah.
robotics things. Uh, the processing of the LiDAR array, sort of all the later readings you have, you could add a step to check whether it's a wall or an obstacle. For example,
How can I know this, Rodrigo?
what is the difference when you look at an RVIS, for example? You look at the wall and you look at the obstacles. For example, the obstacles have a lot of, they're very short, and then there's a big gap for the back of the wall or whatever is behind it, and then it goes back. So there's those sections of LiDAR are very short. And on the other side, the wall is a very long, continuous LiDAR. So one example I can give you, and this is how people do object recognition, and then, for example...
Yeah, of course. But Rodrigo, in this way, I will use object detection, I think, because...
you don't even have to do object detection. You could do, this is just one idea, for example. If you don't want it to go to the obstacle ever, you could just look at every array and the next one, you know, so in a for loop, you look at the current one and the next one. And if there's a big distance jump, let's say the first one is 2 meters and the next one is 5, then you know that there's been an interruption there, and it can't be a wall unless there's a hole in the wall. But in this scenario, that's how you could recognize. Oh no! Even though this is the smallest value, there's a big reading jump when I would expect it to be really small. So that way you can say, oh, then discard that and move forward. That's just one, but I'm just suggesting things for you to sort of get encouraged and continue on that.
I will try to do it in that
because
future.
You're right. This isn't part of the project, and you went above and beyond the requirements. So really, really well done on that.
Thank you.
And let me see what else I thought about. So what would you say the main difference is between a service server and an action server?
Okay, a good question. See, so this is a nice thing in ROS2, because the first thing, service and actions, they are not in ROS1. It's a new thing that it's added, or a new tool that it's added in ROS2. Now, let me talk about the services. Services have only one thing that it can give you, true or false, or it can give you only the result. Yes, no, we can say like this. But in the actions, you are having 3 common things. You are having result, you are having goal, and you are having feedback. So if you are having a project that you need feedbacks from it, like I will give you an example that I get it from the course. Now, if you have a registration of a face recognition system, what you are going to use? You are going to use only the services, because you don't need in it feedbacks, and you don't need in it topics. You want only if the face is recognized, true. If it's not recognized, false. So this is a simple thing that you can use for it. This, but like if you like, I will give you another example of actions. Like if you want to make, like, how can I say, if you have a robot and you want to make a robot in a restaurant, and like you want to tell the robot, hey robot, go to that point or go to that point. So in that way, you need some feedbacks, and you need some points, and you need some things that it's not only yes or no or like this. So this is the main difference between action and services.
Yes, awesome. Just one thing though, you mentioned that this isn't available in ROS1. It is. It is available, yes. But you described perfectly the difference. And another thing that action servers allow you to do is do something else in your program in the meantime. For example, in this wall following example, you're computing the odometry and, you know, computing the entire distance of your robot while you're moving, you're detecting your LiDAR, and you're doing all of that. If it were a service server, it would block everything until you get that true. But yes, that is a very good explanation. And for example, you can take action in an action server based on your feedback. Let's say your feedback says the distance is supposed to be decreasing, but you see an increase in your feedback. then you can take corrective actions in that. In that way, action servers sort of allow you more than just that true or false you said. So yes, great answer. And I mean, other than that, Ghassan, I think that's it for me. Again, really clear explanation, really good project. So I want to congratulate you again and encourage you to continue this
And
robotics
also,
path.
I hope to see you in the in ROS2 Intermediate and in the ROS2 Advanced. I hope
Oh, I'm
I will be
excited.
doing.
Yes,
I will
let's.
not stop at the first step of basics.
All right, yes.
I hope.
Then we'll keep an eye out for you, and maybe we'll see a lot
Maybe after
more.
three months, we will have again this a set and
All right. Oh, by the way,
uh,
one last thing I want to thank you for, and it's that first challenge you talked about, the first challenge you had between the simulation and the real robot. So
yeah.
that was on purpose to sort of show the differences between a simulation and a
So
real
Diego,
robot.
and one thing, I don't know, it's from you the wrong or not from you, like from your course, or you wanted to make it a trick for the students. You know, in the wolf finder part, what you said that from the tips that you give us, or from the steps that you should make the robot at 270 degree or value, which it is wrong. So I don't know if
270.
let me 1 minute. Can I share my screen or because
You
or
mean
no,
in
no,
the
let's
instruct?
only
That's
discuss.
fine. But yes, I will take a look because I was gonna say, you're right. This sort of
Yeah,
confuses
because you
students.
mentioned for the students that who was doing the project that you should make the robot align to 270. But like
Right,
if you can mention if you will only mention you don't give them it's 180, but mention that simulation is not like the real robot because like if you are saying to me put it at 270 and I'm putting it 270, it's not working. So
right.
it's yeah.
Right, because it's the same in degrees and the amount of values in the simulation. So what we're going to do based on your challenge
Thank
here
you.
that you
Thank you.
suggested is that we're going to set them equally so people don't have this problem that they don't even know what's going on. So thank you for pointing that out to us, and we'll make sure to implement it.
Thank you.
But again, Ghassan, congratulations. And I just want to mention to everyone else that's watching, you can do what Ghassan did here for his project once you're completed some of our online courses. So I encourage everyone that's watching to do the same. Well, that's it for us. Thank you, Ghassan, so much for your time, and we'll see you soon.
See you.
All right, guys. See you. That's it from us from Becoming a ROS Developer. See you guys in the next video. Bye-bye.
Okay, Rodrigo, you stopped, yeah?
Yes, I